We are still adding and subtracting rational expressions, but now we are going to look at those ones that do not have the same denominators anymore. Well, students really love that. That is a student's nightmare. Let's try to make this in a happy movie. That looks kind of scary. Here's again the thing. It is the exact same thing as for fractions. Again, yes indeed. So if we were to remind ourselves how we did it with fractions, so maybe you didn't do it exactly this way, so let me maybe show you how this can be done. If I have 7 over 15 and I want to add to this 4 over 9, the very first thing that I will do is I will look at the denominators, and if I can, I will factor them. For numbers, we have either prime numbers or composite numbers. These are composite numbers. That means they can be factored. 15 is the same thing as 3 times 5. 9 is the same thing as 3 times 3. Now what I have to do first is I find my least common denominator. The way to find this is by just starting with any of these factors, and I pick all of those. I pick the factor of 3 and I pick the factor of 5. Now what I will do in my second denominator, I will just look for extra factors that I did not have yet. There is one factor of 3 in my second denominator. I have already one factor of 3. But there is a second factor of 3 that I did not have yet. That means I also need to have 2 factors of 3 in my least common denominator. I do not actually need to know what number that is to be specific. So in other words, in this case, the least common denominator between 15 and 9 is in fact 3 times 5 times 3. That is the number 45. This is the number 45. I'm not interested in the number 45. I'm interested in the missing factors in my denominators. Here, in my first one, I have a 3 times 5. That means there is one 3 missing. That means I multiply the top and the bottom by 3. In my second fraction, I look, there is a factor of 5 missing. That means I multiply the top and the bottom by 5. Now, I didn't really change anything in the numbers because we know that common factors could be cancelled out. But when I look now at my denominators, they have 3 times 3 times 5 as a denominator. Now I can multiply this out. 3 times 7, that is 21. And now I can multiply this out. This is 45. Plus 4 times 5, that is 20. Also now over 45. And that means now I'm back at our examples from before. Let me just write it out. 21 plus 20, that would be 41 divided by 45. 41 is a prime number. This is all I need to do. So let's apply this for rational expressions. It is the exact same idea. I see 2 denominators, x squared minus 9, and a longer one, x squared minus 5x plus 6. So the very first thing that I will also do is I look at these denominators and I will factor them. As I mentioned before, factoring is the most important tool that you need to know how to do. Alright, now I'm factoring the second one. That will be, let's have a look, x minus 3 times x minus 2. Alright, so here are my fractions in the factored form. And if I would know, write down the least common denominator, the LCD, then I look at my first denominator, and there are 2 factors, x times 3 times x minus 3. I look at my second denominator, so in other words, I have 2 factors. Now I look at my second denominator, there is a factor of x minus 3. I don't need that because I have already 1. But there is also a second factor of x minus 2. Now that I don't have yet. and that therefore needs to come. So the least common denominator in this case is x minus 3 times x plus 3 times x minus 2. So there are three separate factors. Now I'm going to do the exact same thing as I did when I was looking at numbers. I'm looking at the denominator, compare it to the LCD, and I'm introducing missing factors. In my first fraction, there is the factor of x minus 2 that isn't there. So I squeeze this in kind of like here, on the top and on the bottom. Now I'm looking over on the right side. There is a factor of x plus 3 missing. So I'm introducing it on the top and the bottom. Now I didn't change again anything in the values. I was just introducing an extra factor on the top and the bottom. So if I would write down this problem, then it would look like this. 7 times x minus 2 divided by this long factors x minus 3 times x plus 3 times x minus 2 plus 3 times x plus 3 divided by x minus 3 times x plus 3 times x minus 2. This is very long, but not really all that complicated. So I am now doing the exact same thing as I had in denominators in the sections prior to this one. I will now just add the numerators and divide this by the common denominator, the long one, x minus 3 times x plus 3 times x minus 2. Now, I am simplifying the numerator. I am distributing the positive 7 here and the positive 3 over there. I multiply it out. I'm getting 7x minus 14 plus 3x plus 9 divided by, yes, all of this. Now I look at the top and I am simplifying. 7x plus 3x, that is 10x. Negative 14 plus 9, that's a negative 5. Divided by all of this. All right, you might think that you are done, but as always, look for common factors in the numerator and the denominator. I can, in fact, a moment, is there something that we can factor out? No, I don't see. Well, the numerator can be factored, but there is no common factor to be found. And that means that we are done. That means this one right here, the 10x minus 5. It can be factored, but it would be just 5 times 2x minus 1. Now, there wouldn't be any common factor on the denominator. That means this long one right here is, in fact, our answer. All right, let's do one that is a little bit shorter. I want to add these two rational expressions, and I am doing the same thing as before. I'm looking at the bottom. This is 2 times 5 times x squared plus 7 divided by 3 times 5 times x. The least common denominator is going to be 2 times 5 times x squared. So these are two x's. And I look at my second denominator, 3 times 5 times x. Which ones do I not have yet? There is this factor of 3 that was missing. one factor of 5 I have, one factor of x I have as well. That means this one on the top right here is the least common denominator. And what factor is missing in my first fraction if I compare it with this? Well, let's have a look. The factor of 3. What factor is missing in my second one? Well, that's a little bit trickier to see. The 2 isn't very difficult to see that there is a factor of 2 missing. But these are x squares, and I have only one x in here. And that means that there is a factor of x that is also missing. Now I'm cleaning all of this up, and in the future you can write this down shorter, smaller, if you know what you're doing. But right now I'm down and writing down every single step. So I have 9 divided by 3 times 5 times 2. That would be 30 x squared plus 2 times 7 times x. That would be 14x divided by 30x squared, and now I can just add the numerators and I'm done. There is nothing that be cancelled out. That x on the top and an x on the bottom cannot be cancelled out. These are not factors. Alright, let's do one that looks a slight little bit different. 2 divided by x plus 3 plus 4 divided by x minus 3. So if we are planning on adding those two, there is nothing really you can factor. So let's remind ourselves, what did we do with numbers when you couldn't factor like these ones, 2 over 7 plus 3 over 5? Well, these are both prime numbers, and that means the LCD was just 7 times 5, 35. The same thing works in this case. The LCD is just x plus 3 times x minus 3. You just multiply them together. And if I understood this, then I'm doing the exact same thing as before. I take my first fraction and I introduce the factor that is missing, x minus 3, top and bottom, and in my second fraction the factor of x plus 3 was missing. So if I rewrite this here to make it look a little bit nicer, then I have 2 times x minus 3 divided by x minus 3 times x plus 3 plus 4 times x plus 3 divided by x minus 3 times x plus 3. Same denominators. That means now we can add the numerators. So I have 2 times x minus 3, and I want to add to this 4 times x plus 3. Everything divided by x minus 3 times x plus 3. I am simplifying, and then at the end, the last step will be again that I will look and see if I have common factors. So I got 2x minus 6 plus 4x plus 12 divided by, this is really all mostly just writing down again stuff that makes this look very long, but you always just focus on one thing. And in this case, you just focus on the top. Alright, I'm simplifying by combining like terms. 2x plus 4x, that is going to be 6x. Negative 6 plus 12, that's going to be plus 6. Divided by x minus 3 times x plus 3. No common factors. The numerator could have been factored. I don't really need to do this. You can write down the answer as in the step before. But if I would factor, then there are no factors that can be cancelled out. So you are allowed on the homework to just write down this as a final answer. Now, the last one for today. Let's do a subtraction problem, and also one that looks a slightly little bit different. Sometimes students are being thrown off when they get problems like this. So, what am I going to do? Well, if I would write it maybe slightly different, maybe then it becomes a little bit clearer. 1 is the same thing as 1 over 1. Now I see denominators. There is not really any denominator in the second one other than 1. So that means the least common denominator is just x plus 5. So what I'm going to do with my second fraction right here, I multiply the top and the bottom with x plus 5. And what I will get now, I have x divided by x plus 5. And I subtract from this x plus 5 divided by x plus 5. This is the same thing as the number 1. In the same way that, for instance, 2 divided by 2 is 1, 5 divided by 5 is 1. So x plus 5 divided by x plus 5 is also 1. Now I just proceed as before. I have already parentheses around the numerators. That means I'm getting this x minus x plus 5 divided by x plus 5. And if I now open up the second set of parentheses, I get negative x and a negative 5 divided by x plus 5. And what simplifies here is that the x's go away. X minus x is 0, and I'm left with a negative 5 divided by x plus 5.